Hi, and welcome to our 10th test and measurement video. Today we're again looking at the Keysight MSO X4054A oscilloscope. We're going to focus on the onboard demos. To get started, perhaps before powering up the oscilloscope, you'll need to hook up two standard 10-to-1 passive probes equipped with hook tips. Previously, the probe should have been compensated and color-coded to indicate the proper channel. If you look closely at the output connections of the oscilloscope's front panel, you'll see that there are two terminals labeled Demo 1 and Demo 2 with a common ground. Connect the probes to the proper terminals and to analog channels 1 and 2, being careful to have good connections and the correct channels. Turn on the oscilloscope, and after it is finished booting up, press Default Setup to clear any unwanted screens from the last work session. Sometimes channel 1 only is active. Don't worry, the oscilloscope will turn on channel 2 as needed. Touch the Help menu icon at the lower left corner of the screen and toggle to the demo menus. The demo categories begin at the third item, Training signals. This is the most elementary of the demos. Any of over 30 signals can be selected using the touch screen, the selection knob, or toggling with the soft key. After a few seconds, the menu will go away, or else you can remove it so it won't block your view of the display. In most cases, it is necessary to push Auto Scale to see the waveform. Touch the menu icon at the lower left corner of the screen. Other than training signals, the categories are Debug Examples, App Demo, and Auto Demo. These demonstrations do not appear on customer-purchased units. The training signals, on the other hand, are available in the DSO-X-EDK option. Additionally, there are labs that can be obtained online. We'll look at the app demo. The subcategories, each having a corresponding soft key along the bottom of the display, are Serial Bus, Advanced Triggering, Advanced Math, Power Measurements, and Advanced Features. Systematically, one at a time, you can go through each of these categories with subsections and read the on-screen information. Pushing Serial Bus, we land on the first demo, I2C serial bus signals. This contains some really advanced technical material. The short description at the top tells which installed option is needed to trigger on and decode the signal. In this case, it is DSO-X4EMBD I2C SPI option. Touch the Help icon at the lower left corner of the screen and press About Oscilloscope to see if you have the option. Whether you do or not, it is good to find out about this interesting protocol. Type I2C into a search engine and you will have lots of information. Originally developed by Philips Semiconductors, I2C has been an open source since 2006, and there are no licensing fees. At present, a number of companies market substantially similar implementations. I2C is a multi-master, multi-slave serial bus configuration characterized by flexibility, wide usage, and low cost. It doesn't require much investment in hardware, making it ideal for in-the-box and on-the-board applications. It is often used in RF tuners, video encoders, decoders, and audio processors. Philips intended their innovation for inside TV sets, for communication between microchips, and for very short spans between boards. Obviously, in debugging a new application or repairing an existing piece of equipment, the oscilloscope's ability to visualize I2C inner workings is of great value. Shifting to another demo, it is worthwhile to take a look at some fast Fourier transform material. Go back to the Help icon and press App Demo. From there, navigate through advanced math, to the FFT demo. We see the FFT math function being performed on a clock signal. Only one channel is required for this operation. The frequency domain, shown in purple, is the FFT translation for the time domain signal, which is shown in yellow because it comes in through channel 1. Touching the on-screen button labeled Next, we see successively an integration transform of a digital pulse stream, an absolute transform of an amplitude modulated signal, a low-pass filter function with a cutoff frequency of 5 MHz applied to a digital pulse with ringing, a measurement trend of frequency of an FM burst, and a chart plot of a logic bus with binary codes converted to temperature. Other valuable demos are accessed by pressing soft keys associated with advanced triggering, power measurements, and advanced features. Thanks for watching. In our next video, we'll look at some more advanced oscilloscope functionality.